Our next question is given that a bomb at rest explodes into three fragments of equal masses. Two fragments fly off at right angles to each other with velocities 9 meter per second and 12 meter per second. We have to calculate the speed of the third fragment. So let's say this is a bomb whose with mass capital M. Now, when it explodes into three fragments. So let's say these are the three fragments, and first two fragments they fly off at 90-degree to each other. So let's say their final velocities be v1 and v2, and one fly off in this direction and other in this direction, and this is 90 degrees. So using the Cartesian plane, this is the velocity and the velocity vector. So this should be 9 along the y-axis vertical, it's 9 j cap, and this is v2 is 12 meter per second along the horizontal x-axis. So this is 12 I cap meter per second. This is 9 j cap meter per second. We have to calculate the speed of the third segment. Let's say third fragment flies with velocity vector v3. So let's find out the v3 vector and we will find its magnitude. So according to law of conservation of momentum, if momentum is conserved, so initial momentum is zero because the bomb is at rest, and that should be equal to the final momentum, which should also be equal to zero. So according to law of conservation of momentum, initial momentum is equal to final momentum, and final momentum is given by the momentum of the three fragments. Initial momentum is zero because the bomb is at rest. Final momentum should be the mass of the first fragment into its velocity vector, mass of the second segment into its velocity vector, mass of the third fragment into its velocity vector. And it's given that the three fragments are of equal masses. So let's say M1 is equal to M2 is equal to M3 is equal to M. So 0 is equal to this is M V1 vector plus M V2 vector plus M V3 vector. So 0 is equal to M into velocity vector plus velocity vector. Okay. Now let's put in their values. So M will come this side. So this is now 0. Velocity vector 1 is 9 j cap and this is 12 I cap plus v3 vector. So v3 vector is equal to negative minus negative I cap. Okay. But we have to find the magnitude. So let's calculate the magnitude. That should be the square root of the scalar component, sum of the scalar components. And 9 square is 81 plus 12 square is 144, which gives me square root of 4 plus 1 is 5, 8 plus 4 is 12. This is 225. That should be equal to 15 meter per second. So the velocity which the third vector will fly off is 15 meter per second. Okay, so thank you for watching.